today's class, let us learn one more method to solve a quadratic equation, that is completing the square. Sometimes you will be given with a quadratic equation where solving it by factorization method is not so easy. Say suppose you are given with the equation, say x square minus, say something like this. Okay, now this is the easiest one I'm taking. Okay, in this you need to solve this. Now you have to check for this number whether it is a perfect square number or not. Okay, if it's a perfect square number, then work is very easy. Okay, so since it ends with 1, then the root of this must be must end with 3, not 3, in fact must end with 1 or 9. Okay, so it must be, I guess, 31. Yeah. So x square minus 31 square equal to 0. Now I can write x minus 31 into x plus 31 equal to 0. A square minus b square formula I'm using. So x equal to 31 or minus 31. Right. This one, it's nothing but, since it's a perfect square number, it is quite easy to solve. Okay, if you have an equation ax square plus bx plus c equal to 0, where b value is very large and factorizing the middle term is quite difficult, in those cases we check for perfect square, whether it is exist or not and all. Okay, I'll solve such problem. Initially I'll take different types of problems. Okay, suppose you are given with this, say x square plus 6x plus 9 equal to 0. I'm taking easiest examples first. Okay, see, in this case factorizing can be done, no issues. Okay, but I'm explaining you how to do with the perfect square method, completing square method. We know this formula, right? A plus b whole square is nothing but a plus b into a plus b, which is nothing but a square plus ab plus ab plus b square, which is nothing but a square plus 2ab plus b square, right? We know this. So if any quadratic equation of this kind, then we can directly substitute this by this. Okay, so we have to check whether I'm getting a quadratic equation in this form, or whether I can rewrite the given quadratic equation in this form, so that it will be a perfect square, and solving them is quite easy. Okay, so completing square method is that only. You have to check. Okay, say a square, instead of a you have got x, no problem. Then 2ab here. Can I write this 6x in terms of 2 into something? Yeah, I can write. So I'll write it x square plus 6 can be written as 2 into 3 into x plus 9, I can write it as 3 square equal to 0. Now, I'm sorry. Yeah. A square 2ab and b square, right? I repeat, a square 2ab b square plus b square is equal to 0. So this is in this form now, right? So I can directly rewrite this as a plus b whole square equal to 0, right? Now this is same as writing x plus 3 into x plus 3 equal to 0. Product of two terms equal to 0 means any one term is equal to 0 or both of them can be equal to 0. So x plus 3 equal to 0 twice, that's same as writing x equal to minus 3, and the roots are minus 3 twice. Okay, same root, it has got same roots. Two roots, of course, you since it's a quadratic equation, you will get two roots. In this case, two roots are same. Okay, so this is the way you have to check when the quadratic equation is given to you, whether you can rewrite it like this or not. Okay, if it's of this kind, then perfect square, you can directly go ahead. If it is something like this, includes bx term, then you have to check with this. I'll take up one more quite different one. You have got x square minus 4x equal to 5. Okay, these are all solve for x by using completing square method. See, now if I write like this, x square minus 4x minus 5 equal to 0, then I have to check whether I can write it in this form or not. A square is a square, it is there, no problem. 4x I can write it as minus 2 into 2x, but this 5 I cannot write it as a perfect square number, right? So it's quite difficult in this case. So for that, what I'm doing is I'm just taking the equation as it is, x square minus 4x equal to 5. Now what I do is, x square is there, no problem. This minus 4x I can write it as 2 into x. Now see, I have to add something to this so that this left hand side will be a perfect square. What I have to add? I have a square minus 2ab. b is 2. I need to get b square over here. So what I do is, I'll take up this b and I'll take a square of that, that's 4. If I have added 4 to left hand side, then I need to add it to the right hand side, right? This is the new number I'm adding on both left hand side and right hand side, or you can write, say I'm just adding and subtracting the whole equation by 4. Hope you got x square minus 2ab. This was my b. Okay, I want b square over here, which is not there, so I'm just adding that b square to both the side. Now this is in the form a square minus 2ab plus b square, right? That's same as writing a minus b whole square, isn't it? Either plus or minus, a square minus 2ab plus b square equal to 0. In the sense, a minus b whole square equal to 0. So same thing I'm applying here, and keep the right hand side as it is. 5 plus 4 is 9. Now you take the square root of 9 plus or minus square root of 9. It's plus or minus 3. Now you take x minus 2 equal to plus 3, or x minus 2 equal to minus 3. When x minus 2 equal to 3, then x equal to 5. If x minus 2 is minus 3, then x equal to minus 1. Got the point? These two are the roots, 5 and minus 1. Of course, even here also, once you get the roots, in any method you can use, and if you are getting roots, then please cross check by putting this in left hand side of the equation. Just put x equal to 5, it's 25 minus 20, it's equal to 5. So your answers are correct. You check with both the answer. This is a quite different problem. Okay, this was direct and this was quite indirect. So you have to check. You rewrite the equation whether you can write it or you can get this in this form, then no problem. If you cannot, then try to add b square. Once you add to left hand side, of course you need to add to right hand side. Okay, we'll go for one more problem. Solve this. Say x plus 2 whole square minus 25 equal to 0. This is a direct problem. In fact, this is same as writing. You can just rewrite this 2 plus 25 and x plus 2 equal to plus or minus root 25, which is nothing but 5. Once you take it to plus 5, next time you take it to minus 5. So x equal to 3 or x equal to minus 7. These two are the roots. Instead of giving this, they may give you like this. Same problem. They may give you something like this: x square plus 4x minus 29 equal to 0. Same, they are same. Just you cross check. Now see, this is x square. This can be written as 2ab. You have got 29 over here. I can't write its roots, right? So I'll just take it to the right hand side. Now for this, a square plus 2ab, b is 2. So what I'm doing is I'm adding b square to left hand side, that is 4. If I have added here, then I need to add it to the right hand side also. It's 4. So what will happen over here? It's a square plus 2ab plus b square. So I can write it as a plus b whole square. And the right hand side is 29 plus 4. So it's 33. Right? Now, x plus 2 whole square equal to 33. How come it should not be? Sorry, it must be 21. Now it will be fine. I'm sorry. Yeah. So that it will be 25. Now this was the same question, right? So always look at the problem. They may give you in the easiest way or like this. Then you have to rewrite it into a perfect square or a complete square. Okay. The next problem is quite different one. Suppose you have this 3x square minus 5x plus 2 equal to 0. So observe one thing in this. So far you are getting the equation where a was a complete square. In this you had coefficient 1, so it's a perfect square. Already it's a perfect square, so you can directly apply a square plus 2ab. Even here you had a perfect square. Even this, so that you can directly apply this formula, a square plus 2ab, like that. But here what I'm getting is I have a coefficient 3 and this is not a perfect square now. So to make it perfect square, what I have to do? I just have to multiply this by 3 so that it will be 9x square. I need to multiply by 3 to whole of this equation, not only for this. This is same as writing. See, when the quadratic equation is equated to 0, it won't matter if I multiply any number to it. Value won't change, right? So, see, even I'm multiplying to this side also in the sense. So, which is equal to 0 again. So, it won't matter when I multiply the whole equation by any number. Now, when I have multiplied this will be 9x square minus 15x plus 6 equal to 0. Now, no problem with my a. It's a square. A is 3x now, right? Minus 2ab. Can I write it like this? It's a is 3. 2 into 3 is 6, but 6 into something won't give me 15, right? So I'll just write it like this, plus 6 equal to 0. Thing is, I have a 3x square, no problem, but this one I have to write it in terms of 2ab. What I do is, right, 3x whole square minus 2a, 2a, b, I need to calculate the b so that this will be equal to 15x. 2 into 3 is 6. 6x I am getting. So if I multiply it by 5 by 2, what will I get? 2a and this as my b. 2 will get cancelled and it is 15x plus 6 equal to 0. Now this I'll rewrite 3x whole square minus 2ab. I need to write 6 in terms of square of this. It's quite difficult. So for that what I do is, this is, I'm assuming it as b, right? I'll just add b square to both the side. That's 5 by 2 whole square to both the side. Or I'll just subtract and add 5 by 2 whole square. Value won't change. Now this whole thing is a square minus 2ab plus b square. This I'm keeping it as it is, okay? That's 3x minus 5 by 2 whole square plus 6 equal to 5 by 2 whole square. Now 3x minus 5 by 2 whole square. I'm taking this 6 to this side. This is 25 by 4 minus 6. That's the same as writing 1 by 4. 3x minus, 5 by 2 whole square is 1 by 4. Same as writing 3x minus 5 by 2 equal to plus or minus root 1 by 4, which is nothing but plus or minus 1 by 2. If you take it as 1 by 2, if you take positive value, then it's 3x equal to, it goes this side, so that's 6 by 2. 6 by 2 is nothing but 3 and x equal to 1. If you take a negative value, that's minus 1 by 2, then 3x equal to minus 1 by 2 plus 5 by 2. So it's 4 by 2 and 4 by 2 is 2, so that x equal to 2 by 3. You got two roots. Since it's a quadratic equation, you are getting two roots. One value is 1 and another value is 2 by 3. Is it okay? This is another method. Okay, like same method, completing square method only, but the problem is quite different. Here the coefficient a is not a perfect square. If you find this one quite difficult, then I'll explain you this with another way of writing, okay, another way of solving. That's, we are just looking at the coefficient, depending on that we are following. Okay, first thing, if a is not equal to 0, what you have to do is, if a is not equal to 0, not equal to 1, then divide the quadratic equation by a. Okay, first step. Same problem. Okay, the problem was 3x square minus 5x plus 2 equal to 0. I solved it using one method. This is also completing square method only. I did by using this. Okay, I'm just multiplying here and doing. This is quite different way. Depending on this a, I'm doing it in another manner. Okay, if a is not equal to 1, then divide the quadratic equation by a, and then write the quadratic equation in the form x square plus bx equal to c. Write the quadratic equation in this form. Afterwards, add b by 2 whole square to both the side. What will you get as this? X square plus bx plus b by 2 whole square to both the side. Okay, you are going to get this. Once you get this, you can rewrite the equation, or you can factor the left hand side into a perfect square like this. You can write this as x plus b by 2 whole square, which is equal to c plus b by 2 whole square. Now you take the square root on the both side. Take the square root so that you are getting x plus b by 2 equal to plus or minus root of c plus b by 2 whole square. So that then you can simplify to get the value of x. Now if I have to solve this same problem using this method, okay, here a is not equal to 1, so divide the equation by a, so that you are getting x square minus 5 by 3 x plus 2 by 3 equal to 0. This was the first step. Second step is to write the equation in this form. So x square minus 5 by 3x equal to minus 2 by 3. Once you write it like this, then you have to add b by 2 whole square to both the side. Here a is 1 and b is minus 5 by 3. I need to add b by 2 whole square. B by 2 is minus 5 by 3 into 1 by 2, so it's minus 5 by 6. B by 2 whole square is 25 by 36. That I have to add to both the side. So x square minus 5 by 3x plus 25 by 36 equal to minus 2 by 3 plus 25 by 36. Now you can directly write this. When you have got this, this is in the form x plus b by 2 whole square. Here the negative sign is there, so minus 2ab. What is b here? It is 5 by 6. So I have to write this in the form 2ab. 2. If I write it like this, then I need to add, if I have added 2, then multiplied 2, then I have to divide it by 2. Plus 25 by 36, and you simplify this as 36 minus 24 plus 25. This is x square minus 2ab plus b square 5 by 6 whole square equal to 1 by 36. This is now a square minus 2ab plus b square. So you can write directly x minus 5 by 6 whole square equal to 1 by 36. Then x minus 5 by 6 is plus or minus root 1 by 36, which is nothing but 1 by 6. You can take x minus 5 by 6 equal to 1 by 6. If you take it to this side, this will be x equal to 1 by 6 plus 5 by 6, which is 6 by 6, which is equal to 1. And if you take a negative value, that is minus 1 by 6, then x equal to minus 1 by 6 plus 5 by 6. So x will be equal to 4 by 6, which is in turn 2 by 3. So same value we got. So here 1 or 2 by 3. Same thing we are getting over here. The question may be this: why I have written it like this? You can skip these two steps. And you can directly write this, but you have to look at this number. Okay. Here in this case I'm getting, so no issues. Otherwise you need to rewrite it. So you better to simplify this. First you find out, before doing this, you just look at this number. It's a perfect square number, so it must be 5 by 6. But I have here 5 by 3. So to make it 2ab, what I have to do? That you have to think. Okay. So this is a quite easy way if you have a not equal to 1. Okay, this way also you can do, or you can do even with this, the earlier method which I do. You multiply by the multiply so that to make this will be a perfect square, and you can go ahead, or you try to remember this way and do it. Another problem, it's 4x square plus 3x plus 5 equal to 0 is a quadratic equation, and have to solve. I have to find the roots of this by using completing square method. Check over here, it's a perfect square, so no problem. 4x can be written as 2x whole square plus 3x plus 5 equal to 0. Now I have to write this 3 as 2 into something. So for that what I do is I'll multiply by 2. But I want 2a over here. It is not there, so again I have to multiply by 2, so that this is a, this is 2a, and this is b. Since I have multiplied 2 twice, in the sense I have multiplied by 4, I need to divide this by 4. Plus 5 equal to 0. Now this is same as writing 2x whole square plus 2a, and b comes out to be 3 by 4 plus 5 equal to 0. Now it's a square plus 2ab. b is this. I want b square over here. Rewriting this might be difficult, so for that sake I'm just adding b square to left hand side and right hand side. or add and subtract b square to this. So 2x whole square plus 2ab plus b square 3/4 whole square plus 5. Again over here also I have to add 2x whole square, 2 into 2x into 3/4 plus 9/16 equal to 9/16 minus 5. Now a square plus 2ab in plus b square, so you can directly write 2x plus 3/4 whole square equal to minus 9/16 minus 5, so it's 80 minus 9, so it's 71 minus 71/16. Here the problem arises. When you get a negative number over here, taking square root is not possible. You cannot write 2x plus 3/4 is equal to plus or minus square root of minus 71/16, right? In the sense, see, I cannot give any value to x so that this whole square will be negative. It's not at all possible, right? Always, whatever the number is, when you take a square, it will become a positive number, right? But here, any value I can give. I can give positive or negative value. But once I take a square of that, I'll get a positive number only. Here, this is not the case. Irrespective of value of x, the value I'm getting it as a negative number. That should not be the case. It won't happen. So we say there is no real value of x. We say no real value of x which satisfies the given quadratic equation. Satisfies the given equation. In the sense, the quadratic equation given has no real roots. Therefore, equation has no real roots. Okay. So this is the method of completing the square. In my next class, I'll explain you one more method of solving a quadratic equation, that is by using the formula. Okay. Thank you.